Hello, welcome to this session. I want to thank Percona first for inviting us to present today. We're here to talk about data protection for rapid recovery at scale. My name is Steve Fingerhut. I'm President and Chief Business Officer of Pliops. Pliops is a company focused on accelerating performance and dramatically lowering infrastructure cost. We're focused on the Flash-based applications driving the most data generation and performance needs. That includes databases, which we'll talk about today, but also analytics, machine learning, 5G, software-defined storage, and more. We've built a team from experts in database, flash storage, and semiconductors. You can see the list of names. We've built that from very strong companies and strong backgrounds. We've been engaged with largest companies to date, over 20 Fortune 500 cloud and enterprise customers. And we have a we're very proud of our investors, and they've given us great support. You can see the leaders there from SoftBank, Intel, NVIDIA, Western Digital, and Xilinx. We've also had a great opportunity to work with Percona, and we have some perspective here from Peter, the CEO, and he had these great things to say about us, which is that our technology turns dumb flash storage into smart flash storage that helps you accelerate database workloads. Percona actually evaluated our product and saw that it was unique in its ability to drive performance and compression, as well as reducing write amplification. And a great quote there, Pliops innovations are absolutely fantastic. So once again, thank you, Peter, for your collaboration and for the great work together. And you can click on that link or go to our website to see more of Peter's comments. So we talk about databases. We're going to talk a lot about reliability, but the major goals are, of course, reliability, protecting the data, making sure your database is up for as much as possible, delivering the performance that you need for your users, as well as scaling. Capacity, there's never enough capacity, it's never cheap enough. So you want to be able to use the lowest cost SSDs, including new QLC technology, which gets more density and a lower cost per bit, but you don't want to sacrifice performance. So, and then finally, use all of the above to really do more with your infrastructure, consolidate databases, and reduce the infrastructure footprint as your business scales. So we'll talk about how we can accomplish these goals today. So one of the major challenges in databases is around building a resilient architecture, and we're going to talk today about one where we did work with Percona on, which is around MySQL. And in this case, a very typical setup will be an HA environment where you have a failover to a standby. Of course, you want to have that happen as infrequently as possible by making that a fault-tolerant node. But then when it does happen, you preserve continuity, but there are some challenges there, and you want to recover as fast as possible. So minimize your RTO, minimize any type of data loss or your recovery point. And so your RPO objective as well. Those come with a cost. And then storage, of course, is a key part of providing that resilient architecture. And you want high performance, resilience, and low cost. Of course, like in most cases, it's hard to get all three, so you need to pick 2 of 3. That's at least been the issue today. So really the takeaway is, for building resilient architectures, you want to first minimize failure events for the fewest possible. When those happen, you want to recover as quickly as you can, and that's going to deliver better SLAs for your customers, as well as an improved ROI. A second challenge that we hear a lot of is, and is not a new topic, is managing the explosive data growth that we're all experiencing. And of course, it's been accelerated in the last year as more people spend more of their time online and get their work, school, and play done online. So we're going to walk through a few example scenarios here and kind of the mood of the DBA in that environment. So this is one we've seen a lot of, and we'll go into more detail as well in terms of some specific customer use cases. But this would be somebody deploying MySQL database using RAID 10 with Flash technology, and that way they get the full performance of Flash as well as resilience. But of course, the challenge is that's very expensive, limits your capacity, and in this case, with 4 database instances, there's only 19% free space for the disk, and you can see the mood of the DBA in charge of that. They're busy with firefighting and escalations. You have a second, right? They've used Pliops, and we'll show you how they can use Pliops, but they've managed to serve those same 4 instances, the same amount of data, but now they have tremendous headroom for growth with 70% free disk space. So that, in that case, the DBA is nice and relaxed. It has a nice smiley face. But that same DBA then can actually, with all that headroom, can double the number of database instances on that same hardware and still have room for further scaling. So this is the value-added DBA. This is the hero, delivering both the performance, scaling, and with headroom to grow beyond that. So this is one scenario for how we see managing explosive data growth. All right, and to introduce Pliops and what we're offering, so we have what we call the storage processor. It comes in the form of the low-profile PCIe card you see here, and we're delivering on those vectors we described at the beginning. So number 1, reliability, which we'll show you a lot of data on, is we can deliver what we call drive fail protection, the rough equivalent of RAID 5, the ability to survive a drive failure at 2 times the performance of RAID 0. So really no trade-offs to delivering that high reliability. Performance, you can scale anywhere from 2 times up to 15 times the performance with all else being equal. Capacity can save 6 times the user data to the same amount of flash as you could with a software-based solution. And then efficiency, right? To use the lowest cost TLC or QLC SSDs really for any workload and not have to focus those on cool or tepid workloads that companies are considering today. All right, and so number 1 is of course reliability. So you have here is the advanced data protection checklist. So number 1, you want your data to be protected. You want that to be automated. If there's any types of failures, you want to be able to recover. Those are items that Pliops delivers. You then, of course, want to be able to rapidly recover and ideally only recover the data. You don't want to spend time in rebuild mode, rebuilding an empty drive, which will happen with classic RAID 5. You want it to be accelerated. You want it to be fast. The way Pliops accomplishes that is we do not use read, modify, write, which is the classic RAID 5 method. Whenever there's a write, there's actually multiple operations, which greatly reduces your performance. Virtual hot capacity, right? Do not use a dedicated spare. Use all of the drives to deliver all the performance and endurance as well as capacity and the reliability features required. Full uptime with multiple single drive failures. So if you have a failure, you can rebuild and continue to survive if there are additional drive failures. And then expanded user capacity. Don't have this come with the trade-off, and in fact use all of the capacity of the SSDs and even more potentially. So these are the items that we see as the ideal and that Pliops is delivering. So first I talked about the performance. So these are dramatic numbers, and these are more of an IOPS level view where we can see the comparison of Pliops versus classic software RAID types of architectures, and which many of you consider. So first would be RAID 0. That's the fastest possible RAID solution, which is there's no data protection and your data is striped across all available drives. And then RAID 5, which of course has a lot of challenges, and you can see the performance drop This is why not a lot of companies are using this technology because of the severe performance penalty. But in this case, Pliops can deliver what we call drive fail protection, same types of protection as RAID 5, but without the performance trade-off. So in this case, you can see we're delivering 19 times higher performance, and this is in a very classic 70-30 random read-write workload. And then the other big consideration, of course, especially in databases, is latency. You don't want the average latency to be high, and you do not want tail latencies that can add up over time, especially in a large deployment and cause service issues. So in this case, 4 nines latency is greatly reduced, and essentially there are no latency concerns when you're using a Pliops device, even in a drive fail protected mode. So that's more of the core I/O performance. This shows how the actual database application performs. So this is running on MySQL. You can see the configuration below in a TPCC type of environment. And in this case, in an actual application, you see a 2.5 times queries per second, which is the basic measure for TPCC, 2.5 times RAID 0. So these are really apples and oranges here. One is with drive failure protection, and one is without that. But even with that additional capability and reliability, we're able to deliver higher performance. And then, of course, the latency continues to offer very, very low latency, even at these extremely high performance levels. Now, you may be asking, all right, that's nice. That's when things are going well. What happens when an actual drive fails? What does that look like? So in this case, we're showing, once again, MySQL, that same environment running. We have a couple different comparison points. So you see what traditional software RAID 5 would offer. This is without an SSD storage failure. So this is in normal operation. You have software RAID 0. So this is obviously without any SSD failure, or it wouldn't be running at all. So basically delivering the very best performance that can be accomplished without a Pliops solution. And then that top bar is Pliops with drive failure protection. So you see the 2.5x performance that we noted before. And in this case, we simulated an SSD crash. You can see the performance does decline a very small percentage, still delivering very high performance, actually still 2 times the performance of RAID 0, even when there is a drive failure that is being rebuilt. And then, of course, that happens very quickly, and the rebuild is complete, and you resume to your full 2.5 times performance. So this is really about having no trade-offs. Even when there's a drive failure, your users are probably not even going to notice that there is an issue. Rebuild happens automatically, very quickly, and you're back to normal operation. All right, another trade-off with traditional RAID 5 is the need for a hot spare. And this shows that traditional environment in an example RAID group. So the challenge, of course, is this provides a target to rebuild in case of one of the other drives fail, but that unit is not operational. So you are not getting any of the benefit from a capacity perspective, from a performance perspective, or an endurance perspective, which is a major consideration for SSDs, right? Your 4 drives on the left in this example are being written to, and their endurance is being reduced, or the remaining endurance is being reduced over the lifetime of the drive, which is quite normal, but the 5th one is not. So you're really letting that sit idle without getting any use from it. And of course, you will experience a very significant performance degradation during the rebuild process. And if you're using software RAID, that is going to consume significant host resources as well. That will further degrade application level performance. With Pliops, we have a technology which we call virtual hot capacity, which does not require a hot spare. You can we essentially use a little bit of each drive for that functionality, and we reserve that space depending on the drive count and your preferences. The other nice thing about this is we only it's a very fast rebuild. So as you saw, it happens fast, and we're only rebuilding the actual data. So if your drives are only 50% full, we're only rebuilding 50% of the data, not the full 100%, as would be the case in traditional RAID 5. And the other benefit, which we'll explore more, and we alluded to in the earlier slide, is that we implement inline transparent compression, which means you can use all of the physical capacity of the drives or even more for your user data and not have any trade-off for that RAID parity data. So really, you get the full performance, endurance, and capacity benefits from all of your SSDs. You're not having them sit there idle for the small percentage of times when a drive does fail. All right, so if we look at these from a summary perspective, right, compared to what you're trying to accomplish, right, we see RAID 0, RAID 1 or RAID 10, and then Pliops drive fail protection. First, number one, you want to offer protection for that node to eliminate a failover event. Does not happen with RAID 0, will happen with RAID 1 or RAID 10, and also with Pliops. You also want the ability to have all your capacity available. RAID 0 can offer that, but RAID 1 and RAID 10 cuts that in half. With Pliops, you get it all. Performance during failures and rebuilds. RAID 0 is not really relevant. RAID 10, you'll see a significant degradation in performance during rebuilds, and with Pliops, you see nearly none. Improved RPO and RTO, but that both from a backup and restore perspective can enable a very fast recovery in the event of a failure. Pliops enables that. And in total, you can minimize the downtime with the lowest costs available. So we've talked a lot about databases, and I've used MySQL as an example, and we'll continue to talk about that and show you some specific use cases, but also want to show the range of applications. And really these are representative of the workloads that do run on Flash today typically. So there's relational databases, NoSQL databases, analytics, as well as software-defined storage and file system. All of those are accelerated by Pliops, and there's more information available on our website about several of these, and you can find out more about your favorite application. Usually about this point in the presentation, people ask, okay, so tell me more about how this works in a system. How does it connect? So this is this is a diagram to help you understand that. So as we show representative applications to the top. Once again, those could be anything that you're using, and those are in the processor/operating system. And those actually communicate to an NVMe driver the way they would today. So Pliops presents a block interface, which any operating system, any application will recognize. Those IOs come to Pliops. We then perform the work that we do, all of the data protection, data reduction, et cetera, that we're offering, then output that reduced data set to a very thin agent that will then write to essentially any block device that you present. So in the case of direct attached storage, you can see it can be TLC, it can be QLC SSDs, it can even be Optane SSDs, and we have other data on that on our website. And you get the full benefit of those storage devices. Or it can be network block. It can be iSCSI, it can be NVMe over TCP or over fabrics, and we're really agnostic to that. So that card as well is obviously an icon, but that we are delivering it as a low profile or half height, half length PCIe card. Will fit in any standard server. So basically you can accelerate any application in any standard server with any SSD, whether that's direct or disaggregated. So maximum flexibility to deliver this and to deliver the values we've discussed really in any environment. So to give you an example of how this works in real deployment, so this is actually from a large e-tailer that is deploying Pliops, and they had their current environment, which was on the left. It was software-based. They were using RAID 10, and you can see the system and storage configuration. Once again, there's more details on this on our website, but you can see they were trying to serve around 150,000 queries per second. This resulted in 31 terabytes usable data for their customers that they could store. They've since implemented a Pliops accelerated solution, which will deliver somewhat higher performance in a single server, more capacity, and with drive failure protection. And you can see the CapEx savings, or the system acquisition cost savings, which yields out to a 54% lower cost with essentially the same performance and 58% more usable capacity. This does not even entertain the TCO savings that you will get from moving to one server from 3, the infrastructure savings or scaling that you can get from that additional headroom. So very happy customer, and we'll be deploying more of that going forward. And the second is a top software as a service provider, one that you're probably all very familiar with. And they have a different environment where they went with RAID 0 as their storage architecture, and the concern was that they did not want to pay the large premium, given these are high capacity, right? 15 terabyte drives. If you want to do a RAID 10, or that would be very expensive to deliver that much capacity. And of course, RAID 5 would be unacceptably slow. So they went with RAID 0 and just suffered the failover events when they happened, which run about 600 per year, which was a significant, caused significant concerns and among their operations team, as well as with some customers. And with the Pliops accelerated solution, will get more performance. They'll get the reliability. That node will be reliable, so they will have, as you see here, we estimate 0 server failures per year due to a drive failure, and actually more usable capacity. So in this case, you can see half of the cost, 600 fewer server failures per year across their large environment, more users, and actually 66% more usable capacity. So a very high ROI for that customer, and you'll be hearing more from them and from other customers in the near future. All right, so the key takeaways for delivering reliable databases. Number one, the local node reliability is key. Yes, we have, and this applies to both SQL, relational databases, as well as NoSQL. While we all have, we can't count on local node, we need to assume that there will be failures at some point. The fewer of those, the better, both for the HA environment, but also for a distributed erasure coding type of environment. Less network traffic, less CPU overhead, less reduced performance yields a much better and more efficient environment. However, achieving that fast, efficient data protection with SSDs requires something different, and that's what Pliops has delivered. And we've shown here that advanced data protection for SSDs is possible with no trade-offs. You get actually more performance, you get all of your capacity and reliability. So really 0 trade-off data protection. And I want to thank you very much for your time. Encourage you to come out to pliops.com. We're very interested to hear from you, very interested to have you try out our product. And once again, thank you. And we'll be open to questions as you may have them.